All right, guys, question was asked about problem number 27 on the 1.8 worksheet, so I'm going to work this one out with you guys here. So they tell us the center of a circle is given by this point A right here at negative 3, 3, and then point B, 1, 6, is on the circle itself, and we're supposed to find the area of the circle in terms of pi. Okay, so the first thing you want to do is identify what kind of problem it is. It's an area problem, and start with a formula. And the formula for area of a circle, I believe we went over here, is pi times your radius squared. So the only thing we need to know to come up with the area of a circle is our radius. And to do that, and this is very often the case in problems like this, we're going to go ahead and we're going to graph the information that they gave us right here. And let's see what we've got. Our center is located at negative 3, 3. So this is going to be a little tricky on the iPad right here. But our center is at negative 3, so that's 3 units to the left, and then 3 units up here to the right. So this is point A, roughly, at negative 3, 3. B is located at the point 1, 6. So that's 1 unit to the right, and then 4, 5, 6 units up. So B is located right here. Okay, so from here, I'm going to draw a really bad circle, everybody. I'm sure this is going to look terrible, but it's supposed to be centered at A, and then point B is located on the circle itself. That means that what we just drew right there is a radius, and we've got to try to figure out the length of that piece right over there. We could do the distance formula on this. In fact, I think that's probably the better way to go, so let's switch colors right here, maybe to green, and see what we can do. Been a long time since we've done this, guys, but the distance formula is really a variation on the Pythagorean theorem. All right, so what it is x1 minus x2, close it, and square it. And then we add to that the same thing with y sub 1 minus y sub 2, close it, and square that. Okay, and with these numbers up here, our x and y coordinates are given to us for those 2 points. So let's see what we've got here. So d is equal to a square root of, and here we go. Our 2 x coordinates are negative 3 and 1. And the order in which you do this does not matter. So negative 3 minus 1, close it, square it, plus, and now our y coordinates are given right here at 3 and 6 for the other one. So a 3 minus 6, close that, and square that as well. All right, so where are we here? D is now the square root of, and let's see what we have here, guys. Negative 3 minus 1 is going to be a negative 4. When we square that negative 4, we're going to get a 16. The order didn't matter here, because if you did it the other way, you would have gotten positive 4, but squaring positive 4 and negative 4, both of them are going to get you a positive 16. Plus, how about over here? 3 minus 6 is negative 3. Negative 3 squared is going to be 9. Okay, so D then is going to equal the square root of 16 plus 9 is 25, and by dumb luck, a total coincidence I'm sure, 25 is a perfect square, and we end up then with a 5 for the radius of this circle. So that was the hard part to this problem. From here, I think we've got it. So area then is equal to pi times a radius of 5 squared, and the area of that circle is then going to be 25 pi, and they didn't give us any units right here, so we're just going to leave it generically as square units.